We're back for the last segment of Apidays Interface, and I will be glad to present you our next speaker, who will talk about, again, async API, but in a specific environment, about securely socializing Kafka topics with async API and IBM Event Endpoint Management. And for that, we're receiving Matthew Sherwin, who is software engineer at IBM. Hello, Matthew. How are you doing?
I'm doing really well, thank you. And yes, welcome everyone. Hope you've had a great conference so far. Good morning, good afternoon, good evening to wherever you are in the world. I'm a software engineer working for IBM. I'm one of the technical leads working on event endpoint management. I'm here today to talk through how you can use async API combined with event endpoint management to securely start to socialize Kafka topics like you would any other type of API. So with that, I'll kind of get into the talk today. And first, kind of a little bit of background and a little bit of context. So regardless of the industry and the application, there's been a huge drive and desire and demand for event-driven architectures and applications to address and solve and provide new experiences to customers and to drive new insights into existing business. There's a real desire to be able to react to events in real time, to build a history and a rapport with end users and provide them a really personalized and responsive customer experience. And as I say, potentially even leverage some of your existing systems with an event backbone to, for example, enable use cases like machine learning to perhaps identify things you wouldn't have spotted otherwise. So there's been this real explosion and interest in these systems. Technologies like Apache Kafka being rapidly deployed to provide these capabilities, which is fantastic. But as with all new and interesting technologies, there come some new and interesting challenges as well. A story that we've seen repeated quite a few times is even within the same business, different lines of business will go and start these initiatives to start capturing and making use of these events kind of in isolation of each other. There's all of this wonderful information being captured, but actually, they're kind of almost siloed off from one another, and that provides some challenges. So, as an application developer, you've been asked to create an application which can make use of events, perhaps drive some delightful user experiences. But where's the information? Who do I contact to get access to it? And how do I understand some of the rules of engagement? And how can I quickly get up and running with these events? There's a gap there where they just simply don't have a place to locate this information or even find this information in the first place. There's also a challenge kind of on the other side of the house as well for the administrators of these systems. They are responsible for important things such as authentication and authorization, making sure that only the right users are able to access particular topics or sets of events as per their needs, to make sure that sensitive information, of course, isn't going out where it shouldn't be. But to do that, they're almost a bottleneck. They are constantly being bombarded with requests for access, and they have to maintain and manage that, making sure that the right people are informed and contacted when required. What that admin almost really wants to do is to describe their system like an API, describe the rules of engagement, describe some of the context so they don't have to keep repeating themselves. Now, up until fairly recently, there wasn't really a good way of doing that. But thankfully, in very recent times, something has come along to fit that exact need for event-driven systems. And as I'm sure most people who have been obviously attending the conference today will have heard, there's something called async API. Just to go over it one more time, async API is an open source community and initiative to come up with a specification for event-driven architectures. It's been around for 5 or so years from the very first version. And over time, it has been updated to be able to describe a whole range of event transports. Today you can describe a Kafka cluster, an MQQ manager, a JMS messaging system, all within one specification. And it was inspired by OpenAPI. There was desire, and this quote is from the Async API website, that the long-term goal of the initiative and the community is to provide a specification which means working with event-driven architectures is as easy as it is with REST APIs using OpenAPI as it is today. So as mentioned, it's been around for 5 years. The current major version is version 2. That came into being in 2019, and there's continued work on new versions. So version 3 is in progress at the moment. And while it's brilliant that we have this ability to document these systems, there are a few challenges still, however. So, compared to OpenAPI, it's relatively new. General awareness, while it is being adopted more widely, is still not quite at the same level as OpenAPI. And describing systems as asynchronous systems in this way is kind of new and a bit different as well. So there's a few barriers to entry there. Not only that, the spec is rapidly evolving, which is brilliant. There's lots of power and lots of ways to describe asynchronous systems, but keeping up with that syntax can be quite challenging. And even worse, potentially you could make a mistake or two in some of the subtleties of the syntax as well. So while async APIs are fantastic and the best way to describe an event-driven architecture, there are a few things to be aware of. And while that API definition solves some of the issues which I mentioned a moment ago, there still are a few extra steps which are required to solve all of the problems, such as a place to socialize this for API developers to discover these things, as well as managing access as and when required. Now, this is where event endpoint management comes in to solve those gaps. So what event endpoint management is it provides you the ability to author and manage and maintain an async API definition. It allows you to then push those definitions to a central developer portal where application developers can discover those definitions and get up to speed with them. Subsequently, they can sign up to make use of that application, and that all can then be managed by the administrator as well. So just to kind of go into each of those areas in detail. Well, first of which is, you need the ability to author and maintain. So we provide the ability in our API Manager UI to describe a Kafka cluster using async API. And as you'll see in a moment, we've got a really nice wizard and editor tool. So you could, as someone who's never seen async API before, get up to speed and up and running nice and quickly and easily. The benefit of that is that you end up with an async API definition which an application developer will be able to follow, understand, and be able to get value from nice and quickly and easily. Of course, the beauty and the benefit of a standard of a definition like async API is you can then, for example, start to make use of and exploit tooling, so code generation, for example, so you can actually start to create some applications from just the definition on its own. And of course, as mentioned, async API, it's been inspired. It's been inspired by the OpenAPI definition. So some of the structure and the way that an application developer may already be familiar with from OpenAPI, they should be able to recognize that and understand the constructs and concepts there as well. So one thing I just want to mention as well, async API is a really fantastic and vibrant community. It's one that IBM is a part of and has made contributions to. So we have, for example, made contributions around Kafka and security of Kafka, but also equally, we've also provided a full description and binding for IBM MQ. So you could completely describe an MQ queue manager and the semantics around that using the async API definition as well. So we're trying to participate and contribute to the evolution of the specification as we go as well. So with all that, we've got our async API definition, and while that's again a fantastic start and really good to have that written down and noted down, the next step of the story is to make that definition discoverable. What we provide here is our developer portal. So what this developer portal is the one-stop shop where you can discover from across the business all of the APIs that are available to you to make use of for your applications. It's all cataloged in one place, it's searchable, and the API definitions which have been created are presented to you in a nice friendly format, and you're able to those definitions quickly and easily. So an application developer can quickly identify something which may be of interest to their use case, and then they are then able to sign up to make use of that. So the developer portal goes hand in hand with something we call the event gateway. The event gateway is a point of enforcement. It applies policy and other controls to make sure that only authorized applications are able to connect to the gateway and subsequently connect to the real backend system. That is all managed in a self-service manner in the developer portal. And of course, with the event gateway being there as that point of enforcement, you're then able to understand which users are making use of APIs, track their use, interact with them, and even maintain and manage access to your actual real backend system. All of these elements kind of combine to provide that decoupled system that, by kind of definition, is more flexible and therefore less fragile. Not only that, you get the ability to perform interface versioning, so you can start to manage your life cycle and understand who's using, for example, which schemas and so on and so forth. And critically, the event gateway, it works at the protocol level. So, for example, in the case of Kafka, it literally works at the bits and bytes level of the Kafka protocol, meaning that any client can connect to it and think it's actually talking to the real Kafka broker. And as you'll see in a moment in the demo, you can even get error messages back and so on, which look like they come from a Kafka broker. So with all that said and done, and kind of a little description of what event endpoint management and async API can be used to achieve, what I'd like to do is kind of run through a scenario, a demo for you of how this can be applied. So for the sake of today, I'm going to run through a scenario for an airport operator, Acme Airports. We have two users who will be kind of following the stories of today. We have Siobhan, who is a Kafka administrator. She's got a Kafka cluster which is full of events that she knows are valuable and useful, but doesn't quite know how to socialize those. And she has the issues of management and having to provide the information directly to application developers. And equally, we've got Andre, the application developer. He was working on an application to improve user experience at the airport, and he's interested to find out if there's any events that relate to weather. He's thinking that he could perhaps use that information to trigger an alert or push a notification that if a passenger was about to land at an airport and it's raining, make sure that you've got an umbrella handy, or perhaps even go that extra mile and arrange for onwards transportation to a hotel or whatever would be appropriate. Those little details, if you will, which really kind of add to the end-to-end user experience, which only can be provided with events which obviously are happening in real time. So with kind of that flavor, let's start the story here with Siobhan. So Siobhan in this case has an Apache Kafka cluster. This is provided by IBM Event Streams in this case, and we've got a set of topics here full of information which are ripe for use across the business. But the challenge is making sure that everyone is aware that this useful information is available. So of course she knows that we, in this case, some weather or temperature information, I should say, being captured, but no one perhaps is aware of that fact. In combination, the situation is kind of compounded that at the moment, because she's the administrator, whenever someone does want to make use of the cluster, she's the bottleneck. She's the one who has to provide things like credentials. She needs to make sure that they're created with the right levels of permission, and also managing which user has which credential, and have to track, for example, email addresses and so on in case of, for example, some maintenance or downtime. She'd also need to provide a lot of common information as well, so the Bootstrap server address, where to connect to, perhaps certificate information as well. All things which are repeat tedious tasks that ideally she wouldn't want to do, and it's more administration. What she really wants is that API definition to describe all of that, which she writes down once, and application developers can discover as and when. So thankfully, with Event Endpoint Management, she can achieve exactly that. So in the API Manager UI, what we provide is a wizard flow to create an async API definition. And what we do is we've tailored this, so even if you've had no async API experience whatsoever, you're able to create a useful async API document. We call out our key fields, we call out things like summaries and descriptions, which are important to provide context for what this cluster is and the information it contains. But we also try and take the opportunity to introduce async API concepts and the mental model of async API as well, to try and educate and assist her in getting up to speed with async API as well. So examples here are servers. So the async API specification has servers to detail the physical servers which make up the system. Well, in the case of Kafka, that would be your Kafka brokers or your bootstrap address. So we've tied those together and introduced those as a pair. Of course, the same goes for a channel, which of course, in the case of Kafka, would map to a Kafka topic. The final thing that we call out as a part of this flow is security. So one of the challenges is creating lots and lots of credentials, and that has obviously some obvious overhead. What Event Endpoint Management allows you to do is to provide a single credential. In addition, you can provide a TLS certificate for transport security as well, that when the event gateway services a client, that one credential is used for all API traffic going forwards. That means that the number of credentials that Siobhan then has to manage is far fewer, and means that obviously that's a lot less work there to do. So having gone through this creation wizard, she will eventually end up with an async API document, which is then maintainable and manageable through what we call the async API editor. Again, here you get the full async API spec available to you in a nice form view. In this case, you can explore what you've previously created and add any additional metadata or construct or detail that you feel is useful to make the application developer's experience as painless as possible. So we have a form view, but hopefully in time, as Siobhan gets more familiar with async API, she will become more of a power user. If you prefer, you can then go through and create and manage async API in the raw YAML if you so wish as well. So in short, Siobhan has been able to capture her Kafka cluster and some of her topics in async API now, and that's great. We've got the definition. What we now need to do is socialize. So what we have in Event Endpoint Management is this construct of products. Products are groupings of like APIs which are published as one unit. This provides you the ability to version these things, as well as provide additional metadata about what the product contains. And it also allows you the opportunity to mix styles of APIs. So you could, for example, have synchronous APIs defined in OpenAPI and async APIs side by side. The publishing process, once you have your product completed, is pretty trivial as well, as you can see. Another little wizard flow here, you choose your publishing target. And just like that, that API definition that you've created has been now pushed to the central developer portal, has been pushed to an event gateway instance, already meaning that application developers can now discover and start to make use of the Kafka cluster of topics that you've just described. So let's have a look at what that looks like. So here we are in our developer portal. We're now assuming the role of Andre, and having come to this UI, we're looking for weather information, but of course you have a little browse and you see something which is kind of interesting. So for instance, perhaps some flight landing information. Hadn't thought about perhaps capturing some of that as part of his app, but he now knows that we've got some synchronous and asynchronous APIs available to us potentially for his application. But having seen that there's a few bundles here that he might be interested in making use of, he spots a weather product and a weather API. And what he can do in this portal is start to explore this API definition. And what he will actually start to see and review is actually the async API document that Siobhan has authored. So we have a nice, as an akin to the editor, for example, view of that async API document. So if he's not familiar, then he can obviously still get some value from this. If he is has come across async API, perhaps he has some tooling locally to generate some code, well, you can still get that async API definition if he so likes. But you can also, in this UI, generate code snippets, see schema information, and if it's provided, even see some example payloads, all very quickly and easily. See if this particular API, this particular topic, is a good fit for what he's looking to implement. Having identified that this is indeed a good fit, he can go through this very quick sign-up process, all within the developer portal. He associates the application he's working with the API, and with just a few clicks, he's now signed up and ready to use it. Siobhan has not had to be involved whatsoever. He's now got his application associated, and if he then returns to the code snippet view, as you'll see in a moment, that actually will be updated with his application's details, his credentials, for example, which means he will literally be able to take a code snippet in whichever language he chooses, and potentially even grab some of the dependency information, for example, and he can get up and running really quickly. So just to show an example of that, we'll just skip ahead slightly here. So here we have his IDE of choice. He's grabbed a Node.js snippet in this instance, and he can literally run this little application quickly and easily. This is the application talking to the event gateway piece. His credentials are confirmed. It's confirmed that he has access to the backend system. And that real Kafka cluster that Siobhan has described is now being accessed, and the events that that topic contains are now being served to him through the event gateway. So, we've very quickly gone from Siobhan describing this system for the very first time, Andre discovering it, signing up, and he's now got this data to hand, and he's able to then obviously work with it, experiment with it, and integrate it and achieve his business objective. Now, this is kind of the day one side of things. There's still a little bit of management that Siobhan may be interested in doing. So again, in the API manager, she'll be able to see which users, which applications have signed up to use the various products. So here we get a view of all of the applications, for example, that are using some of the products. And from here, she could start sending emails. She could start to manage credentials. And in this case, she's removed access from that particular application to the product. And Andre's application will continue to work up until the point that obviously that removal of access is processed. And as you can see here, we've got an error stack. And because the event gateway is working at that protocol level, we're effectively sending back a response saying, well, unfortunately, your username and password, your credentials for your application are no longer valid. So your application can then, of course, process that as it would do a normal event or access issue here, and proceed as appropriate. So just to sum up, we started with Siobhan with her cluster with some topics and some helpful information. She wants to be able to socialize this as an API to avoid some of the bottlenecking and issues that she's been encountering. With the addition of event endpoint management, she has 3 components available to her to help enable that. She can describe her cluster and the topics in the API manager. She can then publish that to the developer portal and event gateway, meaning that we now have a description in the developer portal of this cluster that allows Andre with his application to be able to sign up to make use of it, and without Siobhan needing to get involved, traffic can then flow from the application via the event gateway and that point of enforcement to the actual cluster itself. This is a little bit of a simple example, of course. This does indeed scale quite nicely. So if you added, for example, another cluster, well, that event gateway can still cover that additional cluster and its topics as well. So Andre's application could then start to consume multiple topics from multiple clusters, but the event gateway is acting as that layer of abstraction. And finally, as mentioned, you can mix synchronous and asynchronous APIs in event endpoint management as well. And with the API gateway being installed and configured, that application again can be extended to make use and sign up to RESTful APIs if that's the best fit for the use case. So finally, just to wrap up, event-driven systems are becoming more and more prevalent to address new and interesting business use cases to be more reactive and deliver new and interesting customer engagements and stories. Application developers are desperately looking to provide that capability, but they're lacking the critical information of what information is available and how to get access to these systems. Equally, admins are trying to share these systems but don't have a good way of doing that. Async API has come along and has really bridged that gap. And with the addition of event endpoint management, we allow you to quickly and easily create and maintain async APIs. And with the combination of the developer portal and event gateway, you can then securely socialize those and provide self-service access to Apache Kafka, along with potentially synchronous APIs as well. So with that, I'd just like to say thank you very much for your time and your attention today. And with that, I'll wrap up the talk. So thank you very much. Enjoy the rest of the conference.
Thank you very much. We have 1 minute for just one question. But again, the thing is let's say, for a company who didn't yet invest into Kafka, and like how long is the learning curve according to your experience?
Yeah, so Kafka obviously is a very complicated. There's a lot of power there. The creation wizard, for example, that I've shown, and the editor there, we've tried to really simplify and bring forward the Kafka terminology, the core Kafka terminology, to the fore, and to help guide. And we've got documentation to go with that as well, and explain some of the concepts of Kafka and how those relate to the async API. So certainly in, for example, workshops and demos we've had with customers in the past, they've been pretty quickly and easily able to go from a Kafka cluster on a topic to a working end-to-end system, as shown here, within an hour. So yeah, it certainly has been helpful to get people up and running. But this is a new and interesting space. It's evolving all the time, and there's plenty of new and interesting use cases out there, which we'll look to help with going forward.
Yeah, thank you very much. I think, it really explained how people, for people who are not ready yet, but who wants to jump in to see all the opportunities, now async API is a lot more stable, a lot of tooling. So yeah, I think, we can really make the match. And then at least they'll know that with IBM, they can do it directly.
Absolutely right.
Thank you very much, Matthew. Enjoy your night. And we will end this track with a speaker that a lot of people have appreciated the talks in the past. She has moved from different companies, but again, she's still the same. It's Aliana Insana, VP Product at WeTransfer, and she will talk about mapping the multi-protocol landscape, and nothing better than talking about multi-protocol after a track on API standards and protocol. Nothing better than that can happen. Hello, Aliana, how are you?
I'm wonderful, Mehdi, and it's wonderful to be back with API Days. Thank you so much for having me.
No, we're really glad to have you. And yes, always with great slides, so that's perfect. And let's go for 25 minutes, 20 plus 5, about mapping the multi-protocol landscape.
All right, let's take it away. So thank you, everyone. As Mehdi said, I am Aliana Insana. I am the VP of Product at WeTransfer, and welcome to Mapping the Multi-Protocol Landscape. So I've only been with WeTransfer for only, about a month now. And it has been truly eye-opening for me to be back on the consumer side, where I'm building the APIs and I'm selecting the API tools. But for many years, for those of you who don't know me, prior to being at WeTransfer, I was a product leader at an API tooling vendor. And that means I've chat with probably thousands of developers about issues that they've had with their API practice. In organizations of all shapes and sizes, we would hear the usual suspects. We don't do design first. We have problems with versioning. New deploys, they create breaking changes. But there were also some other problems, and different teams would express them in various ways. But there were a few themes that I kept on hearing over and again, which I've come to think of as the multi-protocol landscape. Things like, we have legacy services that are never going to get migrated to the new tech stack, or we're adopting microservice architecture, which means today there's a handful of shadow services and a monolith that's still in production. Or our product team keeps saying the words real-time events. So multi-protocol implementations are already prevalent. They're not always intentional, but they're there. And the teams that are wrestling with them have shared some significant challenges to work across protocols and specifications. In my mind, we are well past the point of practicing API monoculture, but it's actually really hard to talk about APIs in any other way. And that, I believe, is a function of overall maturity. Without fostering growth in multi-protocol maturity, our tech, our tooling, even our language can be a barrier to acknowledging and describing how we leverage multiple protocols to create value for our organizations. So this maturity model is, theoretically at least, the backbone of my talk today. And I want to tell you a little bit about how it came about. I originally built it with my team to focus on REST maturity, and that was really lucky because REST is the most widely used architectural style, and we were able to capture some ideas about the end state for the maturity. But there's two things that I actually really like about it. First, it's both intrinsic and extrinsic. The model brought together external things that drive industry's maturity with the intrinsic needs of a company or a team that will either push maturity forward or hold it back. But the second thing I actually really liked is it wound up being sort of universal. As we moved beyond REST, we were thinking about event-driven maturity. We found the same principal forces were at work. And when we compared notes with others in the industry who were also evaluating true maturity, we found a lot of similarities. So what do I mean by extrinsic factors? I'm including things like specifications, a standard description language, something that fosters interoperability, so we're all sort of singing from the same choir sheet, and tooling to extend the capabilities of the humans in that ecosystem. And then what I would call sort of generalized organizational behaviors or practices. Now, these are things like governance that help align any organization's API program. The idea of an intrinsic need is a little bit more abstract, but I like to think of it in this way. It's the answer to the question, okay, well, why? Like, why did you document a code-first API? To make it easier to test, and so I wouldn't have to personally explain it to everyone who wants to use it. Why would you need governance as an organization scales? To help the participants know how to change the system safely while maintaining consistency. You see. The only challenge in using this model in today's talk is that most organizations are still in phase 1, maybe phase 2, when it comes to multi-protocol maturity. Now, I want to make it clear, when I talk about broad multi-protocol maturity, I'm not exactly talking about the GitHub model. When GitHub adopted GraphQL back in September of 2016, it was their original intention that Graph was going to be the GitHub API. And then, as they have a right to, they changed their mind. And so now they support both in parallel. This is how a lot of organizations or teams begin looking at multi-protocol, where it's more like uniprotocol that has multiple parallel lanes, sort of a protocol superhighway. But for today's talk, I want to take us a step further in multi-protocol maturity and to explore the places where those seemingly parallel lines cross, where in order to deliver on behavior in a system, we must potentially traverse multiple interfaces and multiple protocols. Let's start with the basics. First off, is there any evidence that API monoculture is in fact an erroneous perspective? After all, I mean, depending on who you talk to, more than 90% of all services that we work with or build are REST. And as an industry, we've been pushing this protocol Thunderdome narrative for quite some time. You know, 2 specs enter, 1 spec leaves, REST is dead, long live GraphQL. You can see the articles there. The Thunderdome narrative makes an assumption. And it's the assumption that the path of progress is paved by revolutionary change. And what corresponds is that each new protocol, each new architecture is intended to entirely supersede what came before. So as I was writing this talk, literally writing a talk on the multi-protocol landscape, and I'm not immune to this bias. When I decided to make a timeline of protocols and specifications for this presentation, I unconsciously went for this roadmap visual metaphor as though each step represents progress from the previous one. But that's not true. It's actually a lot closer to the truth to think about protocols and architectures as different generations sometimes, but all of which can work in the same company. That means a more accurate metaphor here would be evolutionary change. Each protocol or spec specialized independently to address a different in-market need, and in most cases, each was designed to have a slightly different, solve a different problem. Now, it is very hard to know the exact number of services in production, but we can use Google Trend data as a proxy for interest. So what this chart demonstrates is that for any given point in time, active protocols are more of an array function, rather than finding an inflection point where there's a changing of the guard. So what would I say to the writer of that now 12-year-old Stack Overflow article? I think the rumors of SOAP's death have been greatly exaggerated. A substantial majority of orgs are multi-protocol. When SmartBear in the 2021 State of API Quality Survey asked providers what protocols their companies use, more than 80% said they use at least 2, and 53% use 3 or more. There's also some interesting patterns when you start thinking about legacy protocols, things like SOAP. In a very unsurprising way, larger organizations are more likely to have SOAP services. 70% of orgs that have more than 1,000 devs, for example. But it's not only legacy services that have been around for a long time that use SOAP. In fact, 30% of the companies surveyed that said they've only been developing or providing APIs for less than a year still have some SOAP protocols. And it's not just an artifact of SmartBear's data, because Postman's State of API survey also confirms this use of SOAP. Now, what does this mean? I think one of your first views that many devs will have of a multi-protocol ecosystem is as they survey their own technical debt. Because when a legacy protocol service still works fine and it's independent enough that refactoring isn't required, that's going to be the result. We have a very idealized notion of how technical debt is managed, which prompts us to talk about it like we're on some sort of home makeover show. There's before and after. And we're willing to forget that whatever is before has been in production for 15 years. And after is literally never going to get deployed, because migrations definitionally are a journey and not a destination. And if you embrace that reality, it helps shift the monoculture mindset within an organization, which in turn will change the problems that we ask our architecture, our tools, and our strategies to solve. Now, if we aren't building a distributed monolith, and sometimes even if you are, then microservice architecture is another place you're likely to encounter some multi-protocol deployments. And in a weird way, there's a corollary to technical debt here, because microservices are not really all or nothing architectures. In fact, according to a 2020 developer survey from O'Reilly, only 15% of adopters said that they are developing or migrating 75% or more of their systems to microservice-oriented architecture. The business value corollary is digital transformation. But when you ask in the same survey about microservices challenges, one of the first things that everyone cites, obviously because it's the first thing everyone cites in any of these surveys, is problems with their management. So see Conway's law. But almost as high as organizational overhead were issues around complexity. And microservices have two big complexity problems. The first one is decomposing a business into truly independent services. And the second is managing the resulting service landscape. And both of these issues occur at the intersection of different types of APIs. Now, I love using this diagram from Confluent of microservice architecture bridged with event-driven services. I love it because I definitely think it helps you get the general idea. And if I were using it in more of like a workshop setting, I would love to ask people what's missing. Because literally everyone who is listening to me right now could probably come up with something. The loyalty service or the recommendation service, or what about shipping? The fact is, this is a massive, gross oversimplification. And this is not a simple diagram. That has a lot of implications for multi-protocol, because if we cannot make a representation of a landscape, let alone describe its behavior, how do we manage it? To complicate the matter further, we're not just talking about our own services, meaning those that we create. 70% of developers consume and produce APIs. Another 9% consume only, which means third-party integrations, instead of being a minor concern, are a major component of the service landscape. But we don't control how those services are offered. As formats other than REST gain traction, it's much more likely that a capability you want to integrate will come in a form factor you aren't accustomed to. Now, recently I've spoken with several companies who plan to offer only GraphQL as the public face of their API business. So let's use GraphQL as an example. According to a recent Gartner survey, by 2025, more than 50% of enterprises will be using GraphQL in production. And that's up from less than 10% in 2021. And that's going to happen in the context of increased reliance on third-party APIs, from roughly 10% today to 30% by 2025. So we're building microservices, we're integrating these like polyglot services. Surely we have some tools that work across these protocols. Is tools where we start our multi-protocol conversation? Okay, like it's a start. But quite frankly, our tool chain has a really bad case of spec-based myopia. First off, if it's not REST, there's very spotty or thin coverage for an API developer's existing toolkit. And even fewer tools work equally well with more than one service type. This means that a developer who's working with more than one type of API will necessarily be constantly context switching between tools. This negatively impacts developer efficiency, and quite frankly, who wants to work this way? But if multi-protocol maturity follows this general model, and I would argue that it does, the first place we would expect to see some progress is in the toolchain, specifically around tools for exploration, which is a foundational activity for builders, testers, and consumers. Now, most exploratory tools take the individual blocks of a service, whether those are endpoints or channels, queries, mutations, and you either manually input them, you derive them from a service description format, and it allows users to invoke them and sometimes does nice stuff like save metadata on scope or environment. Based on the model, if multi-protocol deployments were really a thing, exploratory tooling would be one of the first places we would expect to see progress. And this is true. There are now tools out there that can do this for more than REST only. And another place where I've seen some multi-protocol progress is the tooling around checking and testing of APIs and services. Now, checks can be done with exploratory tools, but functional and behavioral tests often extend beyond the exercise of a single endpoint, even a single interface. Integration tests require the ability to chain together multiple sequential service calls, pass parameters from one call to the next. And that means traversing multiple interfaces, potentially written in various protocols. The objective here is simulate the behavior of a system, which means multi-protocol inherently becomes a conversation about behavior. But testing can only reveal if the system acts as expected. The next place for multi-protocol tooling to evolve would be for service design. And there, we would actually call it protocol agnostic. For it to be multi-protocol when it comes out, we have to be able to design with the constraints of the semantics of a particular type of specification. Now, protocol agnostic service design has very little tooling support. There are a few things out there, though, that are worth sort of talking about. One of them is ALPS, which is application level profile semantics. Now, ALPS has been around for some time, and sort of summarize, it documents the stuff and states of an interface. It focuses on properties, things like given name, not objects and actions, without using the particular protocol-specific conventions like get pets. From an ALPS document, you can then generate various standard description formats. I think this is a good start because ALPS helps separate the concerns of design and designing the system from the semantics of any particular protocol. What it doesn't yet do, though, is solve the complex problem of mapping behavior across protocols. Now, behavior-driven development is a framework that tries to solve that problem, but not for APIs. Not specifically for APIs. When used correctly, BDD captures the true behavior of a system, the what, not the how. But as someone who's formerly worked with the staff of Cucumber, I can tell you with some authority that BDD is not always used correctly. And at the present time, even if it were, it still cannot be used to reverse engineer multiple specification formats, as ALPS does. Specifications really inventory the system. Behavior captures how to create business value. And that's important because earlier tactical phase is where we focused on building infrastructure, tools, and teams to implement services. But the first and the primary test of strategic maturity is value creation. Low maturity orgs produce siloed, inaccessible value. As mature, both through the desire to share what they've created and to manage it centrally too, they build infrastructure that's focused on collaboration and automation. The first generation of API tools simplified working with a spec. The next generation of tools will need to wrestle with behavior, working at a level of abstraction, individual building blocks. And there aren't many tools or vendors who will willingly take on managing complexity over creating a simplification. To be brutally honest, it's harder to explain, it's harder to sell. But as we mature our practices around APIs and take on further optimization around value creation or making behavior or capabilities a product, then that is the challenge that it would be most impactful to solve. Now, mature API programs prioritize creating a viable ecosystem where the value is created and shared. And they do this to connect internal applications to speed new application development. As we look at the multi-protocol ecosystem, this is the place where lack of tools or specifications will continue to hold back maturity. It's as though we can't have that conversation because we genuinely lack language for discussing it. But there are some things that we can do. And so I want to leave you with some ideas on how to approach multi-protocol maturity within your own organization. What are the first steps? And I think really it comes from taking what we've learned from building a strong REST ecosystem, and that holds the clues where to go next. Both, by the way, within our own organizations and as a broader community of practice around APIs. So number one, begin by treating all types and services as first-class citizens in your ecosystem. Lean into the places where you've already built maturity, looking at you, REST, and then extend. The almost symbolic next task is commit to documentation and take some steps towards design first for all APIs and services. The first, documentation, is essential for creating discoverable value. And the latter, design first, is really a commitment to shaping our service ecosystem customer first, even if that customer is internal. The next thing is something I will give you advice as a product manager. Start somewhere. You're going to have to make prioritization decisions. And there I have some very general advice that I think works universally, which is make it something small enough to tackle, but large enough to learn from. API governance has in some ways a bad rep, and I never understood why. To me, the larger purpose of API governance isn't restrictive. It's instructional. It's how to allow any participant in a service ecosystem know how they can safely change things and still maintain consistency. That safety umbrella should exist beyond and extend beyond our REST services. Netflix would call this principle the context over control. And as a PM, I love the emphasis on context. This allows teams who have specific domain knowledge to do their work without creating such a broad abstraction that no one can really use it. And the final step here is truly advocate with your tooling vendors. Speaking of Netflix again, when Netflix created their first federated GraphQL API, domain graph service, studio ecosystem, it was formerly a GraphQL monolith, and apparently it was a huge bottleneck. What they had to do was use GraphQL to federate hundreds of microservices to present a unified presentation layer. But Apollo, who was their GraphQL tooling vendor, didn't really do that. But when Netflix worked together to create the GraphQL GraphQL Federation specification, and they did that in 2019. As my best friend's dad always used to say, you don't ask, you don't get. So please make a point of presenting your use cases and working in partnership with your vendors to solve real problems that we have. John Houston Finley defines maturity as the capacity to endure uncertainty. If the events of the past few years have shown us anything, they've proven that organizational resilience is tested more by an uncertain future than by failed products, missed markets, even scandals. Evolutionarily speaking, enduring uncertainty requires participants in an ecosystem to respond flexibly to changing conditions and to recognize when different tools or tactics are required. If we approach multi-protocol in this way, we diversify our expertise internally, and evolutionary change can actually be quick. Biologically, it's possible within a single generation. Adopting a multi-protocol view at the outset allows organizations to optimize delivery, leaning into what these individual protocols and specifications do best to improve the resilience of a solution that we provide for our customers. That optimization begins when we go from focusing exclusively on an individual specification, and we start emphasizing using the right mix of technologies to deliver on a capability or behavior. In other words, it's where we build what we need and not just what we know. Thank you very much.
Thank you very much, Aliana. We have time for I think we have 1 minute. We can ask questions. So, how long it will go? How many protocols can we support? How many layers?
You know, I really think the question is not going to be limited by the invention of a new protocol. It's more about when a protocol comes out and it does something in a more useful way. Like, I think of this when I think of the async API specification. There were event-driven specifications before. They were mostly focused on the event payload. The innovation of async API was really to begin to discuss the brokers, the endpoints, the things that were the infrastructure of the system that made it more actionable for a lot of people. So I think we really will see evolution where it needs to happen. And if you look at the sort of earlier slide of the roadmap, there haven't been that many protocols that have been successful. There was kind of like a whole bunch of different specification formats for REST, but realistically now, Open API specification is the dominant one. I think we do see a certain amount of survival of the fittest here, but I don't think we will ever see the end of the evolution, because the end of the evolution would come at the end of where we currently are finding our stuff. And I think Web3, we're going to see some new things that connect into that ecosystem. When I think about VR and those types of processing, eventually they will also hold some evolution to our current service architecture. So I think multi-protocol is also embracing the resilience to move ourselves forward. And if we don't do it, we're constantly going to be working with a fractioned tool chain. And really, like, who wants to work like that?
I totally agree. And it reminds me, a debate I had on energy, energy solutions. So we had coal and gas and oil and nuclear and renewables, and they all add to each other. We never remove one when they are useful. Once we found they are useful, We never remove one. We never diminish their credit consumption. We just add new layers of new consumption for new use cases or new technologies, right? It seems it's the same here.
Yeah, well, I worked in the energy industry. I can definitely tell you it's the same. You've captured it exactly. And part of it is just because of consumption. I mean, think about the Google survey where they sort of said that there was however many billion API calls, and then the year after the pandemic started, it was increased by 50%. That's huge, huge growth. When you think about things that are growing like this, there has to be more that supports it, and people will inevitably find new things to do with it. So I never look at the question of evolution as having an endpoint. Evolutionary endpoint is like extinction level event. And I just don't see that happening for the web, for using electronic protocols and interfaces to communicate with each other. And, we continue to evolve.
Yeah, no, so it really reminds me of the Jevons paradox. Are you familiar with the Jevons paradox? Also called the rebound effect. When you earn, let's say, optimization on something, you use these new resources to invest on new ones, right? Yep. So it seems when we master SOAP and new technology comes, we focus, we have now time and energy to invest in new type of REST. And then when REST doesn't have any more, let's say, earnings on differentiation makers, GraphQL comes for new use cases, and now we invest in this. So it seems it's always what we have, right?
Yeah, and it means managing a lot of complexity and learning a lot of stuff. But I also see a role for specialization. Like, I wouldn't use GraphQL for everything. It's cool. It does a lot of great things, especially if you have problems with overfetching, but it's not perfect for everything. And so allowing these things to serve out their specialization, serve out their purpose, I actually think is a much more sustainable way of functioning as a company and as an API organization and as an API community, really. So there's always going to be room for more, but adapting to the fact that multi-protocol is kind of a thing, I think will actually help us continue in that stream of resilience. And
an energy mix
anymore, I don't have to worry about actually building it, but I'll be after all my vendors to have it.
So we have an energy mix, we have a protocol mix and a stack mix, and they add to each other, and that's a history.
True.
Thank you very much, Aliana. We're glad to have you and to end this track on protocols with actually matching maturity with protocols and being able to handle them all for their use cases. They are not good. There is not one that fits all. Always one for a use case, and more use case, more protocols.
Absolutely.
Thank you very much.
Thank you so much, Betty. Take care. Bye-bye.
Yeah, thank you, everyone. We are arriving at the end of our Apidays Interface 2022. I was really glad to be the MC of this track and the track of yesterday. As you know, this event is streamed currently in Pacific time zone. In a few minutes, it will be streamed in Asia Pacific time zone. And then in 8 hours, it will be streamed in European time zone. So on a rolling basis. I was really glad also to host all the speakers. I also want to thank the sponsors, especially IBM, our platinum sponsor, and also Web Security, WSO2, and Red Hat as our gold sponsors. I also want to thank all the attendees, the questions, the chat, all that happened on the platform that really feel we're part of the community, and also the Apidays organization team, Baptiste, Denis, Uri, Yvan, Isaline, and all the track managers who have been helping this event to happen. See you at next event. You can go on apidays.global to see next conferences. Most of them will be in person these days and hybrid. But we see you next year for this full Apidays interface online, but we have at least 5 events until the end of the year if you want to see some API community members. Enjoy your day where you are, and see you at next Apidays conference.